Alkanes preparation. Soda-lime reaction. Soda means caustic soda NaOH and lime means quicklime CaO. We need alkyl salts, like RCOO-Na. When it reacts with NaOH, quicklime acts as a catalyst. NaOH caustic soda, CaO quicklime. NaO and COO-Na reacts. Hydrogen comes to the alkyl group. And we get RH, which is alkane, and Na2CO3, which is sodium carbonate. For example, CH3COO-Na, which is sodium ethanoate, reacts with NaOH sodium hydroxide and CaO as a catalyst. Na2CO3 combines and hydrogen comes to CH3, CH4, and Na2CO3 as products. CH4 is methane and alkane is prepared. Please note that reactant is ethanoate but the product is methane. Reactant has two carbons but the product has only one. This is because one carbon goes to sodium as Na2CO3. Let's see another example. CH3CH2COO-Na sodium propanoate reacts with NaOH. CH3CH3, ethane and sodium carbonate is obtained. One carbon is lost in sodium carbonate, so the reactant is propanoate but the product is ethane. Next, reduction of Rx. R is the alkyl group and X is halogen, chlorine, bromine or iodine. Example Rx plus H2, forming. Consider H2 as two hydrogen atoms. One combines with halogen and the other goes to alkyl group R, getting RH. Rx is alkyl halide and RH is alkane. For example, CH3, I plus H2 forming. Considering H2 as two hydrogen atoms. One combines with halogen and the other with alkyl group getting alkane. CH3, I is methyl iodide and the product CH4 is methane. The third way is the reduction of alkenes. In reduction, we add H2. We use alkene with 2 carbon which is ethene as an example. Adding H2, we can use platinum or palladium or nickel at 300 degrees Celsius. 2 hydrogen atoms combine to each carbon at each side of the double bond. The product is ethane and now each carbon atom is saturated with 4 bonds. Now, let's study the properties of alkanes. Since alkanes are saturated, they are usually inert. First reaction is chlorination or substitution of alkanes. In chlorination, methane is added with chlorine. In diffused sunlight, the reaction takes place. Remove 1 hydrogen and add 1 chlorine at each step. This is the structure of methane. 1 hydrogen is removed and 1 chlorine is added. Removed hydrogen add with chlorine forming HCl. And CH3Cl methyl chloride is formed. CH4 is methane and CH3Cl, methyl chloride. Now let's go to another step. CH3Cl again with chlorine. In diffused sunlight, removing hydrogen and adding Cl, forming CH2Cl2 and HCl. CH2Cl2 is called methylene chloride. This add again with Cl2 and in diffused sunlight. Removing hydrogen and adding chlorine, this time CHCl3, chloroform is formed. The structure of CHCl3 is like this. It also has 1 hydrogen to be substituted.
Final step is between chloroform and chlorine. getting carbon tetrachloride and hydrogen chloride.